In this presentation, I would like to share my thoughts regarding what the future might hold when it comes to technologies like ChatGPT. And I would ask the audience to consider what I'm going to say with the following mindset. In 1962, Arthur C. Clarke published a collection of essays. And the first essay in that collection is titled Hazards of Prophecy, the Failure of Imagination. And this is a cautionary tale about the limitations of prediction and the importance of keeping an open mind about the possibilities of the future. And I'd like to add to this by saying that failure of imagination is particularly relevant when it comes to computer technology. So, for example, in 1946, the inventors of the ENIAC and UNIVAC computers believed that by the year 2000, there might be a couple of dozen computers in the world. Now, if we move 30 more years into the future, we arrive at a point where computers are widely being used in business, but the president of DEC believes that there's no reason for any individual to want to have a computer in their home. Now, one of the reasons why making predictions about computing technology is so difficult is that pretty much since its inception, computing power has been growing at an exponential rate. And this observation is commonly referred to as Moore's law. And so what you see here is a graph showing at logarithmic scale this increase in computing power over time. And I would like to draw your attention to the fact that if you look at any 10-year period here, what you see is essentially a 100-fold increase in computing power. And so here's a consequence of this kind of exponential growth. So in its day, the Cray 1 was the world's fastest computer. Its power consumption was equivalent to 10 homes, and if we were going to buy it today, it would cost $55 million. Now, if you go from 1982, 30 more years into the future, we arrive at 2012 with the iPhone 5. And the iPhone 5 is nearly 1,000 times more powerful than the Cray. Now, when it comes to technologies like ChatGPT, they are evolving at an even faster rate. So ChatGPT's brain has 175 billion variables. Its successor, ChatGPT 4, which is expected to be released later this year, will have a brain consisting of over 100 trillion variables. So this is a 570-fold increase in brain size, if you will, in the span of less than 1 year. Now, the implications of this increase in brain size rests upon this hypothesis called the strong scaling hypothesis, which says that bigger brains are capable of more sophisticated behavior. And this seems to be bearing out according to early reviews of ChatGPT 4. They pretty much saying it is a monster compared to ChatGPT 3 or ChatGPT. Now, on the hardware side of things, the CEO of NVIDIA has said that within 10 years, the descendants of ChatGPT will be 1 million times more powerful. And this prediction is based in part on the fact that NVIDIA has been able to increase its computing power 1 million-fold in the last decade and is expected to do it again. So let me do a little bit of math here, right? So if you take the Moore timeline, right, 30 more years gets you 1 million-fold increase in computing power. And what NVIDIA is kind of saying is that they've been able to compress this into 10 years. Now, from an evolutionary standpoint, the human brain is ill-equipped to comprehend large numbers and exponential growth. And the problem is that frontiers of AI are intimately associated with both of these. And so I'd like to conclude my presentation with a quote from Steve Jobs. So in 2005, he gave an address to the Stanford's graduating class. And in that address, he said that computers themselves and software yet to be developed will revolutionize the way we learn. And I would say that future has arrived. And if that's true, then now is not the time for our society to have a failure of imagination.